Hello and welcome back to Human Resource Machine, where I didn't really do any work here. I just undid some stuff that I tried to do previously in an episode that never aired. I think. I hope. I'm not sure now anymore. But I don't think. No, that definitely didn't air. So I'm back to my last solution here on Prime Factory, which has 27 commands, which is great, but 441 steps, which is not that great, but still my best, as you can see. So, yay, I guess. So the problem with this solution is that it's terribly inefficient. But I don't have a good way to make it more efficient. So in that previous change, we'll copy this and paste it here. So we'll work in the third thing here and leave this one alone. And I don't even know what this is, so we'll ignore it for now. But this is where we'll work. So the problem with this is that it's very unoptimized, obviously, in terms of steps, because it's optimized for commands. But I still feel like I need to work with this core algorithm, because I can't think of another one. But maybe that's the flaw. Maybe that's why I can't optimize it. So things that are inefficient about this attempt, or this approach, not attempt, approach. Right here, I start by trying to divide 16 by 15, which obviously is not going to work. It would be more efficient to start with 8. So if I halve this and then start dividing, that should always work. I think. Because yeah, it wouldn't matter if it's 3, then I would do 3 divided by 2 is 1. With 1 remainder, yeah, and then I would do 1, and then I would output 3. Yeah, that would work. It wouldn't be a problem. The thing is that it's hard to get. I can't just say divide by 2. To divide by 2, I would have to set up. That's what I did. That's what I undid basically right there, right now. I can't show you now. Well, I can show you anyway because I undid the change just to get back to that solution because I want to start from there. The problem with that is that I need to divide by 2, so I need to grab a 0, bump it up twice initially just to set it up, which is that's not expensive. That's not a problem. The problem is that I just substitute the division instead of doing 16 by 15, 16 by 14, 16 by 13, 16 by 12, 16 by 11, 16 by 11, and so forth. I just do 16 by 2. Well, 16 minus 2, minus 2, minus 2, minus 2, minus 2, until I hit 8. Oh no, I do that 8 times. That's what I'm trying to get at. I'll do that 8 times. So that's 8 loops with the division basically. And if I do it, if the other way around, it doesn't really matter. It's not better. It's 16 minus 15, 14, 13, 12, 11, 10, 9, and then 8 that fits. That's also 8 times the loop. So I'm not saving anything because I can't. Yeah, no, I can't get the numbers down. Another thing that's very inefficient about this code is that I do. I mean, right here it's not a problem. It's minus 15, minus 15. So that's twice the loop. That's not a problem. With 14, it's twice. That's not a problem. The thing is, the lower the number scat, the worse things get. Like right here, I'll go down to 4, it's not a problem. Actually, that's a bad example, because this one works out very well. That's actually pretty good in terms of steps, I think. This one is going to be worse. Because now I do 10, 9, 8, 7, 6. Okay, now it's 3 steps. For 5, 3 steps. For 4, it's already 4 steps. For 3, it's what, 5. For 2, 7. And for 1, 13 steps, and I already know that once I hit 1 here, I already know that this is prime and I need to output it basically. Where do I do that? let me find that part of the code. It's been so long. Yeah, if I hit 0, I found something that's divisible. Then I bump it down 1, and that means it's only I'm dividing by 1. If the bump minus on the 1 is 0, that means that was a 1, and that means to me that this is prime, so I outbox it. The thing is, to get to that point, I've subtracted 1 13 times in that example, and I didn't need to do that. But now I'm not sure if I'm even able to, because I would have to. I can't change that anywhere because that's all happening in this loop. Yeah, I can't do it. I can't do it. That's stupid. I can't break on that. Because I bump it down. And the only way I could check if it's a 1 is to bump it down again and then jump out of its 0 and else bump it back up. Which would save me from doing the -1, -1, -1, -1, but I would check. That would be 3 steps to check if it's a 1 in every iteration of the loop. So that would be much worse for the steps. What else can I do? What else can I do? I could recreate, like, I think the numbers only go up to 20. Or maybe a bit above that, so I could just set up a list of prime numbers. Because I think that's only really terrible when the input is prime, like 11. Because then this loop just runs and runs and runs and runs and doesn't do anything, and it could have just output 11 from the get-go. But how many steps? See, that's so hard. I don't know if 3 inputs is going to be enough to really save me a lot of steps here. If it were, you know, a longer list of inputs, then for sure it would help. If I just made a list of prime numbers to start off, I would have to start. I don't have to. I don't think 1 has ever been an input. Let's see what we get. 12, 3, 10, 9, 3, 17. That's the lowest we get. Is 3 the lowest? Oh no, 2. 2 is the lowest. Alright. So I would start with 2, 3. What else is prime? How many numbers would I have to... what's the highest number? Is 20 the limit? I don't really... If 20 is the limit, so the highest would be 19. Have you seen 23? I don't think we have. And even if we did, on average it might not matter. I don't think I've seen anything higher than a 20. Yeah, let's just assume that that's the highest one. So what numbers would I have to set up? 2, 3, 5, 7. 11, 13, 17, 19. How many numbers are that? 1, 2, 3, 4, 5, 6, 7, 8. I don't know if that would save me a lot of steps, because I would have to set up all the numbers, which would be quite a few steps, because for 2 I would have to take a 0, bump it up twice. So that's a copy from, a copy to, bump, bump. That's 4 steps. Then to get a 3 I would have to bump again. Yeah, I have the 2 in my hand still from the bumping, so I would copy to pump, that's 2 steps to get to that. That would be 6 total. To get the 5, that would be 3 plus 2. Copy from, add, copy 2, that's 3 steps. 7 is the same, it's 5 plus 2, so copy from, add, copy 2. Oh, actually no, it's just 2 steps, because I have the 5 in my hand, and the same for the 3. The previous one's also only 2 steps. For 11, that's the easiest way to get to 11. 7 plus 2 plus 2. Probably. Or 7 plus 3 bump, doesn't matter. So it would be, I have the 7 in my hand, add 3, copy to bump, so 3 steps. 2 steps for 13, 3 steps for 17, 2 steps for 19, so that would be a total of 4, 6, 8, 10, 13, 15, 17, 20 steps. 20 steps just to set up the prime number list. And then I would have to subtract. For each input I would have to test. So I would do inbox and then sub the first prime number. If that is 0, I would have to have a counter as well that I bump up to iterate over the different prime numbers. That's annoying. That's really annoying to set up. I could start it at 2 though, so that wouldn't be too bad, I think. It would be 1 extra step. And then just start with the prime numbers here, 1, 2, 3, 4, 5, 6, 7, 8. And then with 2, I guess I could break it on 2 things. Like I don't have to check if it's already negative. So if input minus 3 is negative, no, that doesn't make sense. If input minus 5 is negative, then I don't have to check minus 7, minus 11, minus 13, minus 17, minus 19. The thing with all of that is that I have no guarantee that it will actually save me any steps. Because it has a pretty high upfront cost of 20, and then I have to have a loop. That loop would be cheaper than looping all over this stuff, but I don't know by how much, you know? I don't know, let's just try it. I don't know. I don't use anything from 2 to 1, 2, 3, 4, 5, 6, 7, 8 to 9, right? I used 0, 1 and then 23 to 24, yeah. Alright. Copy from 24, copy to 2, bump, bump, that's wrong, bump, bump, so it's a 2 now, and then I copy it to as my counter somewhere else. Right here. I don't use that, right? No. And then I would do copy 2, 3, and bump it. That's so many steps. I don't know if this is gonna save me anything. It doesn't feel like it will. Add 2, copy 2, 4, so that's my 5. Add 2, copy 2. Where am I at now? 7? I think so, right? This is confusing. This is a 2, 3, 5, 7. Okay, 7. Then I do add 2, whatever, it doesn't matter. Copy 2. Add 2, copy 2. That's so many steps, that's insane. So 13, and then I do add 2, I guess. Copy 2, 8. Add 2. No, 2. Copy 2. 9. Yeah, 21 steps with the counter thing that I set up too. It was 20 steps for just that, and then plus 1 for the counter. Now I would need to copy to 0, and then I would do sub what's referenced by 19. If it's 0, go in the outbox because it's prime. If it's negative, done. And if it's not, then bump up 19 and copy from 0. If it's negative, that means that the prime number I've checked is larger than the input. Yeah, so I have to check. I have to divide. I actually do everything I've always done, and if it's 0, then I jump out. Oh yeah, but that means I actually need to set up the next prime number, right? Yeah, because the largest input I've seen is 20, and 20 minus 19 would not be negative. So it would pump it up, and then I would reference an empty field. So I have to set up one more prime number. More steps, not good. What was I at? 19, and I need to get to 23. Yeah. I wonder if it would actually save the 4 somewhere. I don't care. It probably would. But this doesn't feel like a good solution at the moment anyway, so... Alright. And now all I need to do is reset my... This is the only jump back up, right? Yeah. So I could do it here. I'll just do it here. For now, whatever. Doesn't matter. It's not a good solution. Reset the counter to 2. I don't even know. Let's just see what this does. 2, 3, 5, 7, 11, 13, 17, 19, 23. Very nice. I don't think this is going to be better, but it's different. It's something else, I guess. I don't know. I have absolutely no idea if this is horrible, if it's about the same, if it's better, I can't tell. I really can't. I guess I could use the list again, because I don't use it. Huh. I could, yeah, I could reuse the list. That might save a few more steps, actually. Oh, yes! Oh my god, I did not expect that at all. 363, wow, that's really good. I went down what? 80 steps there. With the additional, that's with the upfront cost of 20. That's crazy. Wow. I'm so happy. This is first try at this episode. So much better than the previous optimization challenge went. And I think I could. I don't know. This. I don't know if it would matter. It would be interesting, but I don't want to mess with it, to be honest. Because I don't think I check. No, I don't check. I'd only check if the input is prime. If a factor is prime, I still do that by dividing all the way down to 1. So if I just reuse the list, would that help again? I don't know, it might. Or it might be a wash, I don't know. 2 more optimizations. And we have a little bit of time, maybe? This doesn't have, like, I don't think I'll do anything here. Well, let's look at it at least. I don't remember. Okay, 3 commands. Maybe we can get that. I don't think so though. 3 commands and 500 steps. I don't know. I don't think I can optimize the bubble sort down to 700 steps. I might have to implement a different sorting algorithm. The only one I know, like, yeah, only other one, or the only real, I don't know. The other one I've used is quicksort. Which basically you pick an element and then you just split your input into lists. Like one list is, you make a list that's everything lower than the element, and everything that's everything smaller, everything that's larger than the element, and then I don't remember the exact stuff, but that's basically it. So you split the input list into 2 lists, one that's smaller than the pivot element you picked and one that's larger, and then you have basically everything that's on the in the one list is smaller than everything that's in the other list. So that's sorted, and then you just need to sort the lists, and you do that by just redoing the same thing. You pick an element and do the same thing again and again and again until you have sorted lists, basically. It's kind of weird. I don't know if I didn't explain it very well. You can look it up. It's a very famous algorithm, and it's quick. That's why it's called quicksort. I just don't know if I can implement this here very well, because I don't have, you know, I don't have arrays. I don't have lists or anything like that. I would have to work around all of that. I don't know if it's feasible to do that. I don't know. It would be interesting, to say the least. But yeah, let's not worry about that for now. Let's worry about the commands. Maybe we can get that down. Alright, so let's look for obvious things. Yeah, that's just copying everything until I hit a 0 and then I jump out. That seems very efficient. Copy from 24 to 20, set up the counter that I'm using here. Yeah, that makes sense. And I need another counter for something. I don't remember what. Let's just let it run and see. I don't remember the details of this. Yeah, that's good. I understand that part. Okay. This is where it gets interesting. Okay, I have a 0 and a 1. Oh yeah, okay, that's what I do. Oh yeah, and that's my marker that I changed something. That means that the list is not sorted. I bump both of these up. It's negative, so I change it. I could also check if this is not 0, but it's cheaper to bump it every time. Okay. Yeah, I guess having the 0 here definitely makes sense, so that I know when my list ends. Okay. I see potential for 1 save already. If it's 0, do I use 20 anywhere else? I don't think I do. So if I grab a 0, I go all the way back up. And I reset the counter, and what else? This one. Yeah, no, that wouldn't save anything. I just was thinking I could reset 20 here. Copy to 20 because I have 0 in my hand. It would save steps, maybe. I could make it save steps, but not commands. I'm looking for commands. Yeah, this is tough. I don't see anything obvious. No, I don't. Unfortunately, I don't see anything obvious. Copy from 19. Then I subtract a lower number out of the previous one, whatever. And I can't do it the other way. And I have to have 2. Do I have to have 2 variables for the subtraction thing? It's probably cheaper to have 2 in terms of both commands and steps, but I can't be sure. Yeah, I don't see anything obvious, which is kind of expected. Still, I was hoping. It's just the swapping is so much work. Both steps and commands. Yeah, I don't know, I'll have to think about this a lot more, I think. Because right now I don't have any good ideas. I don't know how to, like, I mean, this is obviously a very unoptimized bubble sword thing, but I don't really know how to make it better. I've never really used the bubble sword for anything. I've never coded a lot of sorting things. I think I coded a sorting thing once, and that was a quick sort, and that was just to code a quick sort. I've never had to sort anything ever, really, manually. So that was never a big thing for me. Yeah, I don't know. What I could do is reuse that number here. But would it save me anything? No, I would have a copy 220 here, and I would remove that, and then rename all the 23s to 20s. Wait, why is that? Why is it like that? I'm confused. Isn't 23 my indication that I changed something? Or is 19 my indication that I changed something? No! 23! And then I start using it as my counter as well? Oh yeah, and then I use it as my counter in the end. That's weird. That's I don't know. Let's not worry about that. Ah, so many green lights. 2 more to go. Who knows how long it's gonna take me? I'll worry about it a little bit off camera, maybe. Yeah, I think I have to, because I am right now. I have zero idea what to do, but I'll get it done. I'll promise. And I'll get it done on my own. We've come this far without any outside help. So we'll keep that going. I hope you guys enjoyed, and I'll see you soon. Bye bye.